One last cheer. Okay, everyone, let's sit down and we can get started. Students, can you tell that we've been eagerly awaiting your arrival, and we're really glad you're here. So I want to thank Dean Janner and Dean Chan for leading our new undergraduate students. And to our students, welcome to Caltech and welcome to Convocation 2024. I'm Kevin Gilmartin. I'm a professor of English at Caltech in the Division of Humanities and Social Sciences, and I'm currently Vice President for Student Affairs, and one of the great pleasures of my life in that role is to get to host this event on an annual basis. So our theme this year is sustainability through science, innovation, and education. As you begin your journey at Caltech, you'll see that sustainability is a commitment that touches most of what we do here. From cutting-edge research in renewable energy to pioneering work in environmental science and engineering, to our own physical development of the campus and our management of campus resources, Caltech is dedicated to addressing climate change as one of the most significant challenges of our time. Today's faculty panel discussion will introduce you to some of the groundbreaking research being done across our academic divisions. And part of our aim with our theme this year was to really invite you to consider joining this vital collaborative effort as you plan your time at Caltech. No one comes to Caltech without an appreciation of the challenges that lie ahead. I know that you were drawn here by our rigorous academic and research environment, and you'll certainly be challenged while you're here in new and unexpected ways, inspired and encouraged to think critically as well as creatively, to experiment and innovate, and to address problems that have no easy answers. But keep in mind, as your Caltech journey unfolds, that it isn't just about the intentions you arrived with, nor even the challenges you'll face in the classroom and the lab. There are countless sources of inspiration and avenues for growth here, and many of them lie beyond the Institute's academic core. We are a diverse community with diverse energies. Do take advantage of the opportunity to get involved in theater and performing arts, in athletics, in our full range of campus clubs and leadership roles. You'll hear from some of our student leaders today, and in campus and community service. And I'll just note here that as a humanities professor who arrived here 3 decades ago with a liberal arts college degree and a university PhD in literature, and at that time I thought maybe I had landed on another planet. I wasn't sure what an institute was exactly. But I've long since come to consider Caltech home. And I've had the privilege of mentoring generations of undergraduate students who opted to add an English major or minor to their degree. So I can attest to this. Not only is there a place for you at Caltech, but there are many places, and please consider exploring them all. Now it's my pleasure to introduce the president of Caltech, Thomas Rosenbaum, who's going to share his thoughts on your Caltech experience and what it means to be joining this extraordinary community. Tom.
Good morning. Good morning. Very good. A warm welcome to Caltech. You are now part of one of the great universities in the world. We start fall term at a miraculous time to do science and engineering. New vistas on the universe have opened with gravitational wave detection. The entanglement frontier promises a new revolution in quantum information and matter. Insights into the fundamental biology, chemistry, and engineering of the human body promise to relieve suffering and prolong life. Machine learning combined with human intuition has the potential to discern patterns that can transform the disciplines. Breakthroughs in renewable energy, water, and climate change are urgently required in the decades to come. Caltech students, postdocs, faculty, alumni, and staff, individually and together, continue to work vigorously to expand the boundaries of present knowledge and to apply their insights for the benefit of society. Shattering boundaries is quintessential Caltech. It makes possible scientific exploits that seem impossible at first, such as a mission to an icy moon of Jupiter that has more water than the Earth and holds the possibility of harboring life. JPL's Europa Clipper launches from the Kennedy Space Center in a little over 2 weeks on a 5-year journey to this pristine world 480 million miles away from the sun. None of this is possible without our shared sense of wonder about the universe. We are knit together as a community by a shared dedication to discovery. The Canadian novelist Margaret Atwood instructed that in the spring, at the end of the day, you should smell like dirt. I encourage you to dig in, to try new things, to get your hands dirty. Undergraduates, you will be immersed in the core, mastering science and engineering from a kaleidoscope of different perspectives. Graduate students, you will be deeply immersed in introductory courses in your option and trying different research directions on for size. Yet there is much more here at Caltech. Venture out intellectually, explore a new topic, an unexpected direction. Sustainability, today's theme, is a great example and one that demands your technical expertise and your passion. Learn from the faculty and from your incredibly talented peers. Immerse yourself in an art project. Engage with music and sports and community service. One of my favorite New Yorker cartoons has 2 women standing in an interior doorway, observing a man in the adjoining room smoking a pipe, staring intently out the window. One woman explains to the other, "George is a deep thinker, but his thoughts rarely come to the surface." I know that Caltech will draw the best out of you. You will create, you will innovate, and you will build community. I wish you a safe and fulfilling year, brimming with discoveries and personal growth.
Thanks, Tom. Students don't miss opportunities to hear President Rosenbaum speak. He's always inspiring. We're now going to hear from 2 of our current student leaders, beginning with Sophie Elam, who's president of the Associated Students of the California Institute of Technology, or ASCIT. Sophie is a senior with research experience in environmental science, focused on ocean acidification and its impact on marine ecosystems. She told me she was up in the Pacific Northwest for the summer working on that. In addition to her academic pursuits, Sophie is a dedicated advocate for student wellness on campus and a leader in forming and fostering an inclusive campus community. Join me in welcoming her.
Good morning. It is with great enthusiasm and honor that I have the opportunity to welcome you all here today. I want to begin by taking us all back to our very first day of school, before any of us even dreamed of being at Caltech. Thinking back to our 5 or 6-year-old selves, I'm sure many of us reminisce on the nerves and excitement that accompanied walking into our very first classroom, wearing our very first backpacks, and wondering when on earth is nap time. 16 years later, and I'm still wondering when I'll take my next nap. Since then, we've all had many more first days of school. Some of them more exciting than others, and some of them more nerve-wracking than others. Your first days at Caltech may be near the tops of both of these lists, and I encourage you to lean into these feelings. At an institute renowned for its prowess of logic and thinking, I've learned the importance of the emotion and passion that fuel us all. I imagine that many of us are nervous about what lies in wait in the terms ahead. I know I am. The challenges we will face and the questions that will be asked of us may be daunting. As scientists and researchers, it often feels like we carry the weight of the future on our shoulders. By no exaggeration, we are tasked with elucidating the mysteries of the universe and providing solutions to some of the world's most pressing questions. But as I voice these questions and these challenges, I know many of us have a spark of excitement. Today, I hope we can take a moment to recognize these sparks. May we reflect on the excitement of the first days past and appreciate the days between now and then that have accumulated to us all being here today. As I encouraged before, let's lean into this emotion. One of the most uniting themes I've observed at Caltech is a shared passion and grit. Where some see challenge, we see opportunity. We come together in collaboration and amass our individual sparks to fuel an inferno. We become an unstoppable force whose commitment to answering questions makes us the best problem solvers in the world. I guarantee you will face obstacles and experience struggle during your time here. It's probably why many of you chose to come to Caltech. But the excitement that you feel today is your best friend. So when you're like me, 3 years down the line with sleep-deprived and jaded eyes, there's still a spark. Foster this spark. Recognize each other's sparks. Our love for it and commitment to STEM is what unites us at Caltech, and in my experience, is what supersedes all other qualifications that bring us here. I invite you to use this to your advantage. Take confidence in your passion for innovation and advancement, and be inspired by others who share this enthusiasm. Know that your passion has gotten you this far, and it can take you further. I believe I speak for us all when I say that we are beyond thrilled to welcome you to Caltech. I can't wait to meet you all and see what fires your sparks start. Thank you.
Thanks, Sophie. Thanks for that. Our next student speaker is Liam O'Brien, who's co-chair of the Graduate Student Council and a PhD candidate in physics. His research focuses on quantum dynamics and many-body systems. Beyond that, he's been deeply engaged in enhancing the graduate student experience and, like Sophie, in fostering wellness and community at Caltech. So please join me in welcoming Liam.
Thanks, Kevin, for the introduction. Good morning to all you new students. I hope that you're well and your move to Caltech has gone smoothly. I know that when I moved here some years ago, I actually arrived too late to make it to central receiving before they closed, and I had to make do my first weekend here without all of my supplies and belongings that I had shipped from home. So if you made it here with all of your things, then you're already off to a better start than I was. Personal stories aside, it is my distinct pleasure to be among the first to officially welcome you to campus on behalf of the Graduate Student Council, or GSC. Lying directly ahead of you, or partly behind you if you're an international student, is a slew of presentations, events, and more information than you'll know what to do with right now. While you may feel overwhelmed by this, or tempted to look ahead to classes and research, I do hope that you'll all take the time to enjoy this week. Every single one of you in the audience today applied to and was accepted by Caltech. You were scrutinized by an admissions committee made up of some of the world's most accomplished academics, and you met their standards. That is no small feat. I congratulate you all on this accomplishment. You earned it. Let this week be a celebration of your accomplishments to this point and a reminder that you all belong here. Don't ever forget that. And while the reasons that you made it here may be clear, what will happen next is not. Graduate school is a long and grueling process, full of ups and downs, but it is also full of opportunity. I won't belabor the scientific and educational opportunities that Caltech presents. That message clearly resonated with all of you, given that you're here right now. Rather, I want to stress the personal opportunities that Caltech presents. one of the pleasant surprises of my graduate school experience has been how benevolent and supportive the graduate community at Caltech is. It is not difficult to imagine how a school that attracts so many high achievers could be plagued by competitiveness and cutthroat practices, but that has not been my experience. Having served as chair of the advocacy committee and now co-chair for the GSC, I have seen time and time again how members of this community pick each other up when things are tough and how they will support and fight for each other. I have seen people of wildly differing backgrounds come together to bond over shared activities, be it running, climbing mountains, political discussions, or even just looking at turtles. Through research, coursework, participation in clubs, and the GSC, I have had the privilege to work with and get to know so many fantastic people from many different places around the world and different walks of life. Wherever you come from and wherever you're going, there is a niche for you at Caltech. It may not present itself immediately, but in my experience, it is there. It may or may not be where you expect it. In my case, my community has been on the basketball court, which I expected, but also in the GSC, which I did not expect. Do not be afraid to look for your community, even if it means foregoing a late night in the lab or at the office from time to time. You're going to be here quite a while, and your personal growth, your personal life and growth at Caltech is just as important as your work. And often, those two tend to positively influence each other. As I wrap up, I'd be remiss if I didn't mention that the GSC will have a table at the resource fair tomorrow. So if you're interested in learning more about us, please stop by and talk to us. We are here to improve your Caltech experience and to help you find the community that I and some of our other speakers have been talking about. And with that, I would like to close by once again wishing you a warm welcome to the Caltech graduate student community and to the next chapter in all of your lives.
Thanks, Liam. And I have to say that one of the pleasures of joining the administrative team here has been working with our student leaders. And I'm often struck when I talk to them that they will share with me that leadership was not something that they had gotten involved in previously in their education. So I encourage all of our new students to consider joining the campus student leadership. We really rely on you for a lot on this campus. So at this point, I want to invite our faculty panelists to join me on stage. And it's my pleasure to be joined here by so many colleagues whose work and I value and whose collegiality I value. So the panel is going to be led by Dr. Jonas Peters, a professor of chemistry and director of the Resnick Sustainability Institute. Dr. Peters has been a guiding force in sustainability research on campus, exploring innovative approaches to catalysis with applications to renewable energy. His leadership of the new Resnick Sustainability Institute is propelling Caltech to the forefront of research and innovation in this area. Joining him on the panel are 4 members of our faculty. Dr. John Dabiri is a professor of aeronautics and mechanical engineering. His groundbreaking work in fluid dynamics has informed a range of applications, from biological processes in the ocean to advances in wind energy. Dr. Azita Emami is professor of electrical engineering and medical engineering and director of the Center for Sensing to Intelligence. Her pioneering research on integrated circuits has implications in a range of fields, including digital communication, biomedical implants, and optoelectronics. Dr. Dianne Newman, professor of biology and geobiology, whose innovative research on the bioenergetics of bacteria extends from understanding chronic infections to exploring microbial roles in environmental processes. And finally, Dr. Mark Simons, professor of geophysics and director of the Princeton Exploration Hub, whose research integrates observational data and geodynamic models to shed light on tectonic processes, earthquake cycles, and planetary geodynamics. So we'll begin with some introductory remarks from Jonas.
Thanks, Professor Gilmartin. Thanks to Liam and Sophie for their introductory welcome to all of you, and thanks to President Rosenbaum for kicking us off. And I would like to add my heartfelt welcome to everyone here, both graduate students and undergraduates. I say this as sincerely as possible. Caltech just rocks, and this is a great place if you're into STEM education and research, and so well done, not just in being accepted here, but also making the remarkably wise choice of joining our cohort. I think I say that on behalf of all of us, and your presence will uplift us and make us better as we hope to help lift you and make you better. So I have a couple, I'm going to talk about the opportunities and sustainability here and how the campus is evolving in this direction. I had a couple of personal reflections I just wanted to add to some of the remarks that have been made, given that I have the opportunity at this time to do so. One is to give you a short quote that when I started as a freshman in college, at the August, above the August library that I studied in as an undergraduate, etched in stone was a simple phrase, and it said, read not to believe or disbelieve, but to weigh and consider. And that made a big impression on me as a freshman starting college. And I have to say, in the world in which we live, those words still reflect true and maybe more true than ever. So as you go through here, you know, a lot of people know what they're talking about and think they know what they're talking about, and inertia can propagate ideas a long way. And one of the lovely things about being in a place like this is that you can challenge those conceptions, push back, and see how sturdy they are. So I invite you to do that, and that again helps us all make one another better and push things forward. A couple other things. One being lean into what you don't know, but what you want to learn. Get comfortable perhaps channeling some of your own academic insecurities, which we all have. We share that in common, but get comfortable channeling that insecurity productively. What a remarkable place to be solvated, I'm a chemist, by so many talented people, and to allow your vulnerability to open up new ways of learning from the people around you. So the smartest kid in the room is often the kid that isn't afraid to do that and to siphon so much they can learn from the smart and talented people all around them. And boy, did that help me get through my undergraduate years and graduate school years. And to this day, I'm still siphoning from my smart students and colleagues. So I encourage all of you to do that. This is a great place to lean into that insecurity, but to do so productively to make yourself better. And then the other thing is to get into college or grad school. Sometimes you feel like you have to cross every T and dot every I. That's the reality of it. And I share a son that's going through this in his senior year in high school, and I'm now painfully familiar with what that experience is like, trying to make everything perfect so that you can get into college or maybe whatever your graduate school application is going to look like. I encourage you to also enjoy failing spectacularly. Caltech is a wonderful place to take chances and take risks. And you know, the secret in science and engineering is that, well, it depends what you're engineering, but often the tally of what you've achieved doesn't reflect your failures. It reflects your successes, your publication records, or the things you build, et cetera. Those are your successes, and things you tried that didn't come to fruition are not in the ultimate tally. And so lean into failing sometimes and then learn from that failure, obviously, and channel that in directions that make you better and help you learn what you needed to learn so that you have another approach to that same problem. So those are a few personal reflections, and then I'll transition this way. Another interesting secret about Caltech is that it's remarkably small and impactful, but I do like to say that for an individual, Caltech is a very large school. And so because of its small, intimate size, it's knowable. Many campuses that are huge are less knowable, and you're kind of like a fish somehow swimming in the open water. Caltech's a little more like a coral reef. You get this intimate environment with all these beautiful things going on around you. And so I encourage you to tap into that, to lean into that. And I think I'm borrowing a little bit from Sophie there. I think that's a special thing about Caltech. It's actually very large for an individual, and you can seize that opportunity. Okay, now we transition to sustainability. That is just Caltech's small, intimate size, and this aspect of the campus has brought a cohort of faculty together from all divisions, all 6 divisions on the campus, and many of the sub-options within those divisions, to create a vision for approaching sustainability research, which also includes adaptation, mitigation, and resilience in the face of challenges that are now upon us owing to climate change and stresses on our natural resources. And we have envisioned pulling the campus together in creative ways, both undergraduates, graduate students, postdocs, faculty, and staff, to dedicate themselves to pursue research topics among the most challenging topics that we face, to try to make progress on some of these issues, and to do it in a Caltech way of doing things. And so to tap into this unique, intimate character of the campus to allow us to envision new approaches, new schools of thought in topics of sustainability that will create something that we don't yet know necessarily where we're headed in some topics, but we had this feeling that if we brought people from different corners of the campus that had expertise in applied physics, in geology and planetary science, and mathematics, applied mathematics, engineering, whether it's electrical engineering or chemical engineering or what have you, biology, bioengineering, so many disciplines, that if we started bringing people together from these disparate corners of the campus in common cause shared by something we share, and that's considerations related to sustainability, that we could create something fundamentally new for the campus, and we hope translationally important for society, for the planet, and the way we live. And so related to that, there's now a new building on campus, and some of you hopefully will have seen it already, but you will soon. And within that building, we imagined state-of-the-art research facilities that are going to be accessible to all members of the campus doing research projects where those facilities can help support them. But the clever idea was to bring these different facilities also into one building that's also dedicated to undergraduate education. So we imagined or reimagined our undergraduate core teaching laboratories, which all of the first-year undergraduates will now hopefully be delighted to participate in, as well as active flipped classroom teaching spaces and common study spaces in the building, so that there's really no separation between academic education and research that happens, especially in this realm. And so my heartfelt hope is that all of you, especially undergrads, but anybody, grad students as well, will wander the new building. You'll find corners of the building which we're providing study spaces for you and gathering spaces for you to network with your friends and to study for your courses. And I think this building has an opportunity to really bring us together in a vigorous way. In an exciting way. So please make it your new home or one of your new homes on campus. I realize the Red Door serves a similar purpose, but I think we're excited to see it sort of begin to take shape. A lot of us, including members on this panel, have been thinking about this for some time. Okay, so with that, I'm going to return to my chair and host a little panel discussion with my esteemed colleagues to my left here. Oh, sorry, we have some slides. I should do that as well. Again, embrace your failures. Okay, so this is one slide of the new building. Have these been rolling through? This is a high bay space. So somehow our administration thought it was wise to have a bunch of professors imagine a building for which we did not yet know what the heck we were going to do in this building. And so we tried to build spaces that would think to the future of types of experiments we might possibly want. So for example, let's say I wanted to do a pilot scale experiment and I wanted to build a giant distillation column. This would be a high bay space in which I can do that. And you can be someone like John Dabiri to my left might want to build a new type of windmill in a structure like this, or as Mark may relay to us, things that will be part of the exploration hub. This is the lobby of the new building. It's a stunning, architecturally stunning building, and it will have shared workshop conference space and lots of areas for common seating that actually are reflected on the other floors of the building. It has a really warm feel because of the mass timber structure that holds up this undulating glass facade and then sort of these beautiful concrete floors. Let's see if we go to the next slide. So this picture shows a gorgeous view of the hallway, and actually it's a stunning hallway with this beautiful, but just to the right is the flipped classroom teaching space. You see a table there. So there was a need that was called out by our education committee to have more collaborative flipped classroom teaching space on campus. So this is our first experiment at really designing this type of space. Let's see if we go to the next slide, or it's coming soon. Great, that's it. Okay, so with that, I'm going to join the panelists, and we'll kick off. Great. Okay, so I'm going to open with a question that all of you will probably have something to say on, but John, if you're willing to lead off, I'll ask you to lead off. So the general question is, how did each of you become excited to direct aspects of your own research towards issues of sustainability, adaptation, and resilience, acknowledging that we all come from very different types of backgrounds? So John?
Great, thanks. And first, let me join in welcoming all of you here to Caltech. I was a grad student here many years ago. I was also a summer undergraduate researcher in the SURF program. And so I'm really excited for the experience you're about to undergo. It's a marathon. You've heard people tell you to pace yourself, and that's very true. But in terms of my pivot to sustainability, I guess fundamentally I'll say, being a person of faith, I believe that God has given all of us unique talents and abilities. And I think we have the opportunity here at Caltech, more than most, to use those to make the world a better place than we came into it. And so in the area of sustainability, I think it was in 2005 or so, there was a movie called An Inconvenient Truth that narrated some of the challenges we're facing in sustainability and what some of the consequences could be if we didn't take action. At that point, all I knew is I really loved fluid dynamics. I loved the physics of flows. To be honest, I was more interested in building rockets and things of that sort at that point. But I thought I'd try to have at least some part of my research thinking about how we could advance sustainability. And it turns out that in the space of wind energy, you've seen, of course, the conventional large propeller-style wind turbines out there. There hadn't been a lot of innovation in that space for quite some time. Because I had a background that was studying the fluid dynamics of fish, for example, coming from that SURF program, the Summer Undergraduate Research Project, I was already in the mindset of thinking about ways in which we could translate ideas from nature to improve engineering designs. And so it turns out that you can take some cues from how fish school in a group. They don't spread apart as possible, but they actually take advantage of the aerodynamic or the hydrodynamics of their neighbors. And we could do something similar in the case of wind turbines. We found that we could get up to 10 times more energy out of a plot of land using that type of an approach. And so that really was a springboard for a lot of our research in sustainability. We have a research wind farm in Alaska where students have gone up to work with small villages where it's very expensive to fly diesel fuel in, but they have great wind resources. And so we've been able to use these smaller wind turbines, small enough to fit into the new sustainability building, and to use that to advance their goal to transition from fossil fuels to energy. And then from there, I think because we were already working in the ocean, we began to appreciate how much we still don't know about our ocean. And I was really glad to hear Sophie working on projects there. And so a big part of our research now is in ocean exploration. It's a place that uses physics and math, biology, We might be the only lab, I think, where all the grad students can scuba dive and solve partial differential equations. So not at the same time, that's dangerous, I'm told. But that's the type of interdisciplinary connection that happens here at Caltech, and I think uniquely at Caltech.
And if I could just follow up then, in terms of your ocean research, is this also related to remote sensing in terms of developments in the oceans in terms of sustainability?
It is. So one of the challenges you've probably heard is that some small fraction, 5% of our oceans have been explored. Most of that is near the surface because we can use remote sensing technologies like satellites. What we've been interested in is going very deep into the ocean. And it turns out that there are already organisms like jellyfish that inhabit the full depths of the ocean, down to 10 kilometers. And so what we've been doing is using jellyfish, which don't have a brain or pain receptors, and embedding microelectronics, the type that Azita develops in her lab, for example. And we can use them as ocean explorers, programmable robots that can swim down. They get their own food by harvesting on prey in the water column. They can withstand those crushing pressures at 1,000 atmospheres at the bottom of the ocean. So that's the vision. Today we're only going 10 or 20 meters. Next year we're hoping to go to hundreds of meters. And we're hoping the Brinson Exploration Hub that Mark is leading can also help us to organize the various talents needed to accomplish a pretty ambitious goal like that.
Great. Okay, so I have a lot of ways I can go here. Thank you for those lead-ins, but why don't I go to Azita first, and then we'll go to Dianne next on a similar question, and you can lean into that. Thanks.
Hi, everyone. I also wanted to welcome you all to Caltech. I wish you all a wonderful start. Going back to your question, working on sustainability and environmental related projects for my group is relatively new, and I have to say it has been greatly inspired by Caltech's collaborative environment and great colleagues such as Dianne Newman and our interactions with JPL. So for many years in my group, we have been working on very high data rate data communication systems. So as you may know, these mega data centers that have enabled AI and cloud computing and everything that we do these days with our smartphones and computers, a big part of what happens in these data centers is moving data around. Many terabits of data per second needs to move around in these data centers. And that consumes a huge amount of energy. So for many years, our research has been to reduce the energy consumption of data communication at very, very high data rates of hundreds of gigabit per second for data centers and high-performance computing. And we've been always interested in applying our techniques, our engineering principles to many other domains, and working on high-frequency systems in interactions with JPL, we realized that we can also use this kind of engineering disciplines to improve, for instance, remote sensing systems. So one of our projects is to model, create statistical models for millimeter wave propagation and modeling atmospheric effects that causes phase scintillation and reduces the accuracy of remote sensing systems. So that has been a very fruitful and great collaboration between my group and JPL. And also over the years, we've been very interested in building tiny miniaturized devices for biomedical applications to monitor health and help patients with chronic diseases. And then after talking to Dianne and other colleagues, and because of the Resnick Institute, we were able to extend this work and try to use the same type of sensors that are low cost and miniaturized to monitor environment and soil and collaborate with biologists to be able to build this kind of sensors that we can monitor the soil, the nutrient level in the soil, and avoid over-fertilization and have a smart agriculture in the future.
Fantastic. So, Dianne, do you want to lean into that?
Sure. Can you hear me? Is this on? Great. So I join my colleagues in welcoming all of you to Caltech. It's wonderful that you're here, and we collectively are really excited about it and looking forward to getting to know you guys. So my interest in environmental science actually dates back to when I was in high school. I was really into debate as well as science fairs. I was a big nerd in high school. And one of the resolutions when I was on the debate team was about acid rain. This was during a period of time many decades ago when acid rain in the Northeast was a huge problem in the United States. And there was a lot of attention on that topic. And it was also a time internationally when countries were beginning to come together in a very four-sided way and develop things like the Montreal Protocol to try to come up with global environmental guidelines to protect the planet. So it was then that I began to sort of recognize the importance of environmental science and have an interest in it. I wound up exploring quite a number of things as an undergraduate, but ultimately I made my way in graduate school to an environmental engineering program where I thought I was going to do computational fluid dynamics to help construct the gates that you find outside of Venice in Italy that are protecting that city from flooding now as seawaters are rising internationally. Yet in graduate school, now I'm looking to the graduate students, my very first semester there, I took a class in environmental microbiology. And I hadn't ever taken any biology until this time. And it completely changed my life because I recognized in this class how unbelievably fascinating the chemistry that microbes could do as part of their metabolism is, and how absolutely transformative it has been throughout Earth history for the planet. And so then I took a really big pivot and wound up becoming a molecular microbiologist, which I am today. And so my research is aimed to understand how it is that microorganisms catalyze reactions that are fascinating from just a very pure science perspective, but also very important in a whole variety of contexts, ranging from understanding how chronic infections are able to sustain themselves to understanding how it is that microbes in any nook and cranny throughout the Earth's environment are also able to thrive. And what I find so captivating about this problem is that a microbe in a community of other microbes really has no idea what is at a distance more than just a few microns away. And so you can study something very fundamental, and yet it can have great and broad relevance to all sorts of important issues. And so when Caltech had this incredible gift to create the next level of the Resnick Sustainability Institute, I was asked to lead the initiative in ecology and biosphere engineering, which was a great honor. And it sort of got me back thinking in the mindset, as I was when I was starting college and going into graduate school, of how environmental problems are ones that are really important and are even ones that in a way my own research can contribute to. And I started leaning into that and directing a portion of my lab's research in that direction. But if I'm being honest, one of the things that got me most excited about this opportunity was not only having some of my own research go in this direction, but enabling the brilliant talents of colleagues throughout this campus, like my friend Azita here, whom I'm now collaborating with, people who really weren't thinking about doing environmental science previously in their careers, but yet had these extraordinary skill sets that could be applied in creative ways to do something really new and impactful. To have the opportunity to be part of that, to catalyze that, was something that I was just really honored and happy to do.
Fantastic. And Duke, I would just as one quick follow-up, I heard the word chemistry in the various comments you made, and I just wanted to ask if grounding in the chemical sciences is one
Yes,
of the
absolutely.
one of the key disciplines.
I will gladly oblige. A large portion of my lab's research is very much based in chemistry. We do chemistry of all types. And one of the things I will encourage now, talking to the undergraduates, you guys have the most awesome labs. Sadly, there wasn't a picture of that in the slide deck. You have some of the most gorgeous labs for learning chemistry that I have ever seen in my life. And So take good care of them. They're pristine, they're beautiful. You're gonna make messes, and as you should, but clean them up, because these labs are just incredibly awesome, and I can't think of a better place to learn the magnificent power of chemical catalysis. So you're gonna have a great opportunity there.
Thank you, Dianne. Okay, Mark, if you would share a few thoughts, and then I'll have a follow-up related to the Brinson Exploration Hub, but start with your own experiences.
All right. Well, I hesitate to say this, but I actually haven't had chemistry since high school. But we won't talk about that.
Get out.
So I'm an observational geophysicist, and as such, you know, I am really motivated to understand the world around me at a scale which is large and a scale which is small. We think about earthquake faults. You can have a magnitude 8 earthquake on a fault that is a few centimeters wide. We worry about plate tectonics. We worry about things the size of moons and planets. And at the same time, we worry about earthquakes that happen in minutes, seconds, and we worry about the millions of years associated with the movement of plates and so on. And as an observational geophysicist, you're sort of always faced with this problem of this juxtaposition of different processes and different timescales everywhere you look. And it becomes unavoidable when you look around in a global sense to see the impact of what we as a species are doing on this planet. And it has led to directions that I did not expect, starting off in thinking about earthquakes. I now spend a lot of my time worrying about glaciers, glacier flow, the interaction of ice streams with the tides at the timescale of days, to how they will eventually melt and collapse, potentially in Antarctica. And the question there becomes, is it over a decade, is it over 100 years, or over 1,000 years, so that we can prepare appropriately? Jonas has talked about both sustainability and resilience as being close to each other. And in both cases, you really need to just, first and foremost, understand the world and what it's doing now, understand the baseline, be able to detect how it's changing. An example is if you can now go from space, taking radar satellites, and look down at the surface and measure with exquisite precision how the ground is moving up and down as we drink the water from the local aquifer, and it gets depleted in the summer and then it refills in the winter. And the problem is, in almost all places that you look, the seasonal cycle has actually also got a secular term, a term that is actually these aquifers are decaying in terms of their pressure and therefore their capacity. And this becomes really a global problem in terms of the access of fresh water, right? And so there's many examples of this that then start to merge what you can observe, and then thinking about how you mitigate against the problem, and then you need to start thinking about how to talk to the engineers and the chemists and so on to understand how we're going to sustain these water use. Another example, which I think is particularly important, is this juxtaposition of anthropogenic effects as well as natural processes, such as large disasters, earthquakes and floods, sea level rise, which is both anthropogenic and natural. To actually understand these processes and to react to them requires really good engineering, and it requires thinking very carefully, how high do I have to build my seawall? We saw, for instance, after the disastrous earthquake in Tohoku, that the seawall wasn't large enough in front of that nuclear power plant, right? And so as we start to think about that and how these natural phenomena then interact with anthropogenic processes, sea level rise, and so on, it becomes really important to understand what the world is doing and the direction that it could go. And so I think as we look around, whether it's at the biological scale or at the planetary scale, it's unavoidable that you are faced with these problems. And the question then is, to what extent do you focus your energy on solving these problems?
Great, and if I can ask, so we're talking a little bit about what motivates us in terms of large-scale problems that maybe we might be able to apply some of our efforts to. But then there's also the spark of fundamental discovery in science. And now one of the joys of Caltech is also our relationship with NASA's Jet Propulsion Lab, which Caltech manages and is closely affiliated with. And now we have this Brinson Exploration Hub that is just kicking off, and that'll also have a home base as part of the Remote Sensing Center or integrated with the Remote Sensing Center. And I thought maybe you would just comment a little bit about that.
So as Azita said, there is an enormous number of opportunities to collaborate with JPL. There are 6,000 people up at JPL. There's 2,000 people who publish papers on a regular basis up at JPL. And I had the fortune of being the chief scientist of JPL for about 7 years until about a year ago. And what was extraordinary, one of the things that we discovered or recognized was that there's just an enormous number of fantastic ideas of things that have been developed, algorithms that have been proposed that just fall on the floor. And we lacked mechanisms to actually implement, to test, to deploy, to launch, to set it underwater, and so on, as we heard from John. And so we had this vision of, at a smaller scale, we're not trying to duplicate JPL by any means, but working with JPL to have the two institutions work together to actually explore, figure out how do we explore the Earth, the solar system, in ways that we haven't been really able to do before, or at least demonstrate or test technology that will enable this going forwards. And you talked about taking risks and failing earlier on. One of the things one of our tenets is that we should not be as risk averse as we typically are with big, large, billion-dollar planetary missions, for instance. We want to take risks. We want to try things. And so we were very fortunate to have a gift that allows us to have this beginning of this center called the Brinson Exploration Hub. It is housed in the new building. It is hosted in the new building. It has it looks like a mission control. We can't call it that. So it's a science operations center. And it has a space downstairs for building small instruments to go on satellites or to go underwater. It is connected to the high bay. The whole idea is to engage the Pasadena community, Sensu Largo, into the joy of exploration. And in many cases, that same exploration will help us do things or experiment or show the way for things that can have great societal impact going forwards.
Fantastic, thanks. Okay, so I have a spontaneous question that you all can answer at your own free will or choose not to, whatever you want. But I thought before we wrap up, this could be a good one. We'll see how it goes. So if you were looking back at yourself as a first-year undergraduate in college, from where you are now, and you could have a chat with yourself, any advice you'd give to yourself that you would have appreciated at that time with the benefit of hindsight in terms of the studies you pursued or how you approached them or other things, anything you want to say. And I thought I would just throw that out there as a question to chew on and maybe chime in.
Take chemistry.
Take chemistry, yeah.
I owe him $20 for that comment.
I was going to say the exact same thing. I was so focused on math,
I owe you $40
physics,
for that.
and engineering, and I didn't take any biology or chemistry. And I regret it now, but I'm very fortunate to work with biologists.
Well, we love you anyway. We embrace you, Azita. You're doing great work.
I think overall, it's good to focus, but having some knowledge. These days, actually, a lot of the projects are very collaborative and interdisciplinary, and exciting things happen at the boundary of fields, and it's good to know a little bit of other things too.
Fortunately, all of them, at least the first year under, will be taking chemistry, so that won't be a problem for anyone. All right.
I took one chemistry class, and we'll leave it there. But it wasn't taught by you. So my advice would be to pace yourself, two pieces, pace yourself and ask questions. I think that I was really eager to accomplish everything both as a freshman and as a first-year grad student. And it really is a marathon. As Liam said, you're going to be here for a while. I think one of my favorite days here at Caltech is graduation. It's out on the lawn behind us here. And the president gives out awards at that ceremony. There is no award for who finished their degree the fastest or who took the most units in a quarter. I know some of the cards I signed for advisees, you would think it's a competition, but there's no award for that. There's certainly no award for who completes their time at Caltech asking the fewest questions. And yet sometimes I think that's the mindset we have. What the awards are for are people who, again, left Caltech a better place than they found it by building a community here, by pursuing new types of research. awards for opening new avenues of exploration by questioning orthodoxy, like we heard Jonas talk about earlier. And so those are the types of things that I would encourage you to do. They take time, and give yourself time to get used to the place, to get used to the pace of the core, for the grad students to get used to what it's like to do research where your advisor might give you a project where there is no answer, or it's a 10-year answer as opposed to a 2-year answer. They might pretend like they know. They don't know whether it's gonna be a 2-year project or a 10-year project on day one. We have to figure that out together. But give yourself that grace and pace yourself would be my advice.
I would say different things to the undergrads and the grads, although one thing I will say in common to all of you, scientists and engineers, become good writers. All right, one of the things that I'm very grateful for is I had a large dose of humanities as an undergraduate, and as you go forward in your careers as scientists and engineers, your ability to communicate effectively, whether it be orally or by the written word, winds up becoming extraordinarily important. So remember that. To the undergraduates, I also very much support the advice given, which is take advantage of your opportunity to be broad and try to see if things that you may never have thought were going to float your boat before actually do, because you might be incredibly surprised by that. And you have an opportunity. In the United States, you have this kind of extraordinary opportunity as undergraduates to be a little bit broader than in many other places. And this winds up being something that can be a tremendous advantage as you go forward. So take full advantage of that. Because when you get to graduate school, I think the advice becomes a bit different. And that is, now you are directing your own academic quest. And it is up to you to become as expert as you possibly can. And as you walk across the stage to receive your PhD, have the pride that you know more about this little corner of science and engineering in the world than anyone else on the planet. And the only way to develop that level of command over your topic is to focus deeply and to really just get into it. And so I think that you're at different stages in your education in ways that are really wonderful, and they're both incredibly important. And so recognize the opportunities that you have in front of you and have fun and make the most of it and do it in a sustainable way. Now, as a parent, I will say to sustainably do any of these things requires enough sleep. And so it also requires friends. And so make the time for both of those as well.
Maybe I share what advice I would give to myself as an incoming international student, as a graduate student to the US, because I know we have a lot of international students who come from abroad. And so I arrived from Iran as a first member of my family ever leaving my country. And I was very worried. I feel like anxious and nervous, and I was worried about failure, because when you come as an international student, you feel like everything depends on your graduate studies and your research and your success. Otherwise, everything will fall apart. And I look back and I think that was wrong, and that there is so much help and support, and graduate schools, including Caltech, provides this environment for international students to flourish. And it's, as Jonas mentioned, failure is a good thing a lot of times, and we learn a lot. And don't be afraid, and don't be too worried about failing, and have a lot of confidence in yourself and in the community that is around you.
Very, very well said. Chemistry.
I'm done with chemistry. I guess what I would like to just convey is that being in a place like this is a luxury. It's a luxury in society. It's a luxury for us all to have this opportunity. And so you owe it to yourself to give the place and yourself all the opportunities possible. I always say to my students when they show up, you know, our goal is not for you to work on the problem which I've specified for you. Our goal is to find the problem that you are so obsessed about that you go home and you're washing your hair and you go, oh, I know the answer, right? And that's why you're here. Because if you're not obsessed about that problem, you're never going to have that sort of impact that I think most of you are after, right? But that takes time. You're not going to find that problem instantly. So as everybody else has been saying, and I just resonate with all of this, is that give yourself a little bit of grace, take the time, taste a lot of different foods, see what tastes good, and see what recipe you want to start cooking, and so on. It's very important because, you're here for 4 years as an undergrad, maybe 5. You're here for somewhere between 10 and 20 years as a PhD student. It takes time. It takes time. And, but you do give yourself take advantage of that luxury to find that problem which you're going to be passionate about, because your goal is to be a leader in that discipline.
Did you have one more thing to add?
Just one quick addition.
Yep.
Dianne mentioned sleep, which I think is so important. I can see in my eye line a lot of our coaches over here, and so I would say we have great athletic facilities here. Go exercise, go take a walk. It's very easy to get stuck in your room, either just doing problem sets or some of you just doing video games. But getting across the street there, I think, is great. I see Liam playing there. He's really hard to guard in basketball, I've learned. But we have great opportunities for students to not just develop their minds, but their bodies as well. And I hope you'll take advantage of it.
Yeah, exercise is great. And I can confirm, I sometimes see John running in the opposite direction around the Rose Bowl. It's hard to spot you because you're moving so quickly. But if I use my strobe camera. Okay. I want to close it there. So please, everybody give a hand to the fellow panelists. Again, I want to thank the organizers for the opportunity. I also want to take a moment as you now go see this new wonderful facility that's been added to the campus. I just want to close by saying in a heartfelt way how indebted I am and the campus is to the two individuals that partnered with us and had the vision to help us create this facility, Linda and Stuart Resnick. So they really have allowed our campus to do something that's simply extraordinary, and it's an experiment that now we get to watch unfold with time in terms of housing all these different types of research facilities in the building and our undergraduate education under one hub that tries to bring everything together, and with no strings attached, they just gave us this opportunity. So I just want to thank them. They're not here right now, but I just wanted to say that. And with that, I'll pass it back to Professor Gilmartin. Thanks.
Thanks. At this point, I will ask our panelists to step down, partly because we have a video and everyone will be looking over you if you don't. So that was extraordinary, and as I listened, it occurred to me that one person I didn't thank is President Rosenbaum, who actually had the idea for a faculty panel for this convocation. It was a terrific idea. So at this point, we're going to shift a bit to a short video presentation that's going to help introduce our new students to Caltech. All right. Gradually bringing things to a close here. I do want to let the students know that you arrive at Caltech at a really special time in terms of our campus performing arts programs, many of which take place right here, as Caltech joins a Getty Museum-sponsored series of events throughout the whole Los Angeles region called PST, Art and Science Collide. And these are going to be events that highlight the connection between the work being done by contemporary artists and both the history of science and the current leading edge of science. The Caltech version of this program begins on Friday, October 4th in Beckman Auditorium with the performance of Tesla, a radio play for the stage, which tells the story of Nikola Tesla's life as a brilliant but controversial inventor and futurist, and of course the developer of the Tesla coil, and there'll be a series of events after that. Thanks to support from the Friends of Beckman Auditorium, Caltech is offering free tickets to all of these events for incoming students. That's you. So just find your way to the opening doors section of Caltech events website, and I'm told that you should use the code first year, that's all caps and no spaces, to claim your free tickets. In closing, I do want to express my sincere appreciation to all the staff, faculty, and students involved in making today's convention a success, and I particularly want to recognize the efforts of some of our behind-the-scenes staff members, Gordon Alameo from the Student Affairs Administrative Team, Shana Shabner-McKinney and Nate Stuffel from Strategic Communications, Leslie Maxfield from Academic and Media Technologies, Isabel Peng and Miranda Huseth from the Office of Student Experience, and Francis Yokota from Dining Services. And with Dining Services in mind, one last hosting note. Next up is a community lunch just outside on the Beckman lawn. You're all invited, but I want to ask our audience members to allow the new students, led by our deans, to exit first and make their way to the lunch area before you exit and join them. So thanks everyone again. Thanks particularly to our speakers and behind-the-scenes staff.